So this is the building that we will be working on. It is a bank, a brand new bank building, which is attached to an existing structure, which we will not be putting lightning protection on at this time. And here is the roof plan that we'll be working off of, pre-drawn up, elevations already on there. So what we're going to do is design the system for this building using all the details that you should already have intact that Lizardo has sent you. It is the air terminal details, the bonding and splicing details, and all the general notes. I've already placed the general notes inside of the title block area. So now what we're going to do is use the symbols, which are also shown in the typical symbol legend here. And we're going to start to lay out the lightning protection system. We always put the general installation notes on there, which dictates where the air terminals are spaced, where the grounds are spaced. And we're going to start with the highest roof area, which you can see here is marked at 72 feet above grade. What I start to do is offset the parapet wall approximately 6 inches. And what this does is give me a nice offset so I can change it to the cable layer, which will interconnect all the air terminals. I'm going to select the air terminal symbol from the legend and start by placing them at each corner. Measuring the lines, you can see the distance here at 67 feet, which means every 20 feet on center, I'm going to have to divide this line by 4, giving me 3 evenly spaced air terminals. The AutoCAD that I have set up automatically has a divide command using that block. You can turn any symbol legend into a block and divide it by that using a macro. I'm then going to go to the lowest roof and do the same thing. Once again, the air terminals around the outside are spaced every 20 feet on center. Air terminals in the middle of the roof are spaced every 50 feet on center. Once again, starting at the corners, measuring the line, dividing it by 20 feet on center, evenly spacing the air terminals around the perimeter. Basically, I turn those lines into polylines using AutoCAD, which will in turn create a regular distance. Now here's an exhaust fan. So all mechanical equipment on the roof will need to be protected unless it's in the zone of protection, which I'm going to draw here. This canopy that's down below, I'm going to take an imaginary 150-foot radius arc, placing it on the ground level, and then placing it at the highest roof area. As you can see, everything that's underneath this 150-foot arc is in the zone of protection. So that canopy down below is guaranteed not to be struck by lightning. So what I'll end up doing is taking this zone of protection and using it to figure out what needs lightning protection and what doesn't. Then I can go back to the plan, locating that canopy, and then I will hatch that in the zone of protection, showing that it doesn't require any lightning protection whatsoever. So keep in mind, these mechanical units are also located down in a pit. The elevation doesn't clearly show it, so I'm going to draw them in here, but that's approximately where they're located. So since we have lightning rods on parapet for parapet, essentially everything in that pit where those units are located is also in the zone of protection, which means those air conditioning units and condensing units do not require any further protection. Once again, lightning rods need to be spaced every 20 feet on center around the outside, but they also have to be spaced every 50 feet on center in the middle of a roof area. So what I'm going to do is measure this line, and you can see it's almost 100 feet. There's going to need to be a lightning rod placed in the middle. Essentially what we're trying to do is create a cage around this building, so in the event of a lightning strike, it's going to redirect the lightning. We're going to use full down leads on this building since it is a concrete building. So what we're going to end up doing is, based on the building perimeter, which this one is 410 feet, we're going to end up having a down lead and ground every 100 feet on center. I measured that roof perimeter and decided it was less than 200 feet, which means we need 2 drops from the high roof to the low roof. Since lightning can't travel uphill, at the very edges of the building, where you have a high roof to a low roof, we end up placing a ground, since the lightning cannot go back uphill. It flows a lot like water to where it starts at the highest point and then it comes down. So what I'm going to do here is measure the low roof perimeter, 272 feet. I have a little tool here where I can just divide this line by 3. And I'm going to place 2 more grounds in those locations. Because the building is over 60 feet above grade, I'm going to take and install and draw a counterpoise which interconnects all the ground rods. This is building code, and any structure over 60 feet above grade requires that the ground rods be interconnected below grade. And then we'll pick a detail later that shows exactly what that looks like. Since the building perimeter is 410 feet, it requires 5 down leads to ground, and those will be the 5 required per code. So now what I'm going to do is hook up the exhaust fan and the mid-roof air terminal. And I'm going to hook them up from down lead to down lead using the most direct route. Now what we're going to do is pick out which details are associated with which symbol. These are a list of details that you should have already available to you. This detail here is which I'm going to use for the perimeter air terminals. Essentially what we're going to do is pick a detail that's associated with the lightning protection, relabel it, and label the plan accordingly. For this project, we're using an all aluminum roof system and all copper down leads and copper grounds. Depending on the project requirements, this is where you can choose either copper or aluminum, depending on what you're mounting to, and depending on what the specifications of the project dictate. So this detail A, which is the parapet detail, we're going to label in every single location where that detail applies. Next, what we're going to do is label the exhaust fan detail. This detail we're going to label B. And there's only going to be one of those. Next, we have to select the mid-roof air terminal, which is nothing more than the air terminal that's glued directly to the roof surface. This detail will associate with the letter C, and there will only be one of them required. For the mid-roof air terminal, we use a spring point in order to avoid any sort of fall potential hazard. Now what we're going to do is get the lightning protection system from the roof down to ground. This is our typical through roof detail. This shows how the cable is going to be coming through the roof and into the downlead to the ground. This is going to be our most standard copper cable, which is 29X. Then we need to pick out a section that depicts how the cable is getting from the roof down to ground. So if this was a steel building, what we could end up doing is utilizing the building steel as the path to ground. However, since this is a concrete building, we are going to have full cable all the way from the roof into the earth. And this depicts the detail T and T2 on the plan. Then we just have to pick a grounding detail, which is associated with how the lightning protection system enters the earth. You can see the different options here. We've got different steel options. I'm actually going to pick one out of our archives that actually better depicts the system that we are utilizing here. There's different methods of using the grounding connections. We can either do a mechanical connection, or you can do an exothermic connection, or you can actually use high compression fittings as well. For this application here, for the ground detail, we're going to be using exothermic connections. Once again, you're going to have copper cable coming down, and I'm going to use the same copper cable for the counterpoise that interconnects all the ground rods. For lightning protection system, you do have to be 10 feet deep into the earth with the ground rod. So typically what we would do is use a 3/4 by 10 foot ground rod in order to meet that requirement. So that pink cable there is the counterpoise cable. And last but not least, what we end up doing is filling out the title block with the project name, and there you have it. Your layout is done. I will essentially take this, PDF create it, utilizing the PDF creator that's already built into AutoCAD, and you will have a finished lightning protection drawing. We're going to call this sample building, and we'll put it in Peru. I'm going to hit right click on the tab, hit plot, publish it to an AutoCAD high quality print, save it to the location, and there you have it. This will be your final lightning protection layout, designed from the top down, utilizing all the details you're provided. And that's going to be your finished product. So there you have it. I hope this helps.